Hi guys, in this video we're going to talk about pages 326 and 327 in lesson 4 of your science textbook, continuing the question, how do scientists draw conclusions? And so our next set of information involves evidence and inferences. And so scientists base their explanations on evidence, and evidence includes any information you have and observations that you make. An observation from an experiment is a piece of evidence. Facts you already have or research you have that you have done are also evidence. Scientists use evidence to make inferences. An inference is a conclusion drawn from data and observations. For example, the statement, "The tree has no leaves on it," is an observation. "The tree lost its leaves because the season is fall" is an inference. It is a conclusion drawn from the fact that the tree has no leaves. It is possible to draw more than one inference from the same data. When new facts are added, scientists can draw new conclusions or confirm old ones. So when we infer over here, let's start with number 6, Make an inference about which of the balls below, we have some balls down here pictured. We have a fabric ball, a golf ball, a table tennis ball, plastic foam ball, and a rubber ball. Make an inference about which of the balls below will bounce the highest on wood. So it's the same surface this time, and we're just comparing different types of balls and determining which one we think would bounce higher. And so, or the highest. And I think the rubber ball will bounce the highest. So, then I'm going to talk about how I can justify that. If I have experience with all of these, bouncing each kind of these balls. And so my inference is going to be, or my guess, is going to be that I think the rubber ball will bounce the highest. And then I need to justify my answer. What evidence supports my inference? So just like when we are talking about a reading passage and we have evidence, and that's what we can find explicitly stated in the text, when we make inferences, that means we take what's stated in the text and we take what things that we already know, background knowledge, we put those two things together and we can make an inference, which is just a common sense determination about something from what we already know. And then we need to justify it. What evidence supports your inference? So a possible answer might be that I've played with each kind of ball and the rubber ball bounced higher than all the others. And that is what I would say, because I literally have played with all these kinds of balls. And so I know that I'm pretty sure my answer is correct because in my experience, a rubber ball bounces highest out of these 5 different kinds of balls. So I might say I have played or bounced. I have played with each kind of ball. And the rubber ball bounced higher than the others. Okay, and our last question on this page is to infer about the photo of the tree. So someone noticed that a tree had no leaves. and inferred that it lost its leaves because the season was fall. Write another reasonable inference based on this observation. And so think about what are some other reasons that a tree might have lost all of its leaves. And there are two possible answers that come to my mind immediately. The tree had a disease. Trees can get diseases in them, and it can cause them to die. Or the tree is dead. And those are some of the reasons that a tree might lose all of its leaves. Okay, let's look at page 327. Our next topic is about reasonable answers. Scientists attempt to develop reasonable answers to the questions they pose. To do this, they use evidence from their observations and experiments. For the bouncing ball experiment, you would use evidence gathered by doing the procedure from the previous pages. A reasonable answer should not favor one opinion over another unless it is supported by evidence. So this is a really important statement here. You might want to underline it. The next thing that they do is compare results. That's another important step in the scientific process. So scientists often compare their methods or procedures with those of their peers. And peers are, like your peers are the people that you go to school with or the people that you hang out with and play with at home or in sports. But like my peers are other teachers and people, other adults that I know. Scientists are going to compare those with their peers, and they would be other scientists. So they also compare their results. By comparing methods and results, scientists can work to find results that can be retested. In the bouncing ball experiment, one group can compare their results with another. The scientists determine whether the results are similar or different. They try to explain why the results are similar or different. Scientists often do this to think of new questions or better ways to perform a test. And then our question comes here where we have to decide, why is it important to compare results with others? And a possible answer to that would be, comparing results helps to show whether the method and the answers are reasonable. Again, this is a complete sentence. Comparing results helps to show whether the method and the answers are reasonable. And if they're different, then scientists might say, well, let's talk about our different procedures that we use. There may be differences in the procedures, and there may be differences in, and that may be the reason that the answers were different. And so when they compare those, and it helps them to become a little more careful about their procedures and the way that they go about drawing those conclusions. There is an optional activity over here for you if you would like to examine a coin and then list everything you can about the coin that is factual, and that means true, okay? Everything that is true. Next, make some inferences about the coin or the country that minted it. And when it talks about where a coin is minted, it means where it was made. So if it's a U.S. Coin, then somewhere on that coin, on a lot of coins, it will tell you which mint it was made in. Compare your list of facts and inferences with those of your classmates. And obviously right now we can't do that since we're not in our classroom. But you could compare those with your friends through a chat or through texting or a phone call. That would be great. Or in one of our Skype meetings. So, in the next video, we will cover the last 2 pages of this assignment, which are pages 328 and 329.